Hello guys and welcome to Python programming tutorials by Amulya's Academy. We were discussing about binary search tree implementation, and today in this tutorial we'll write a method for deletion operation, that is how to delete a node from the binary search tree. While performing the deletion operation, the first step is we need to check whether tree is empty or not. If tree is empty, we can't delete any node from that, right? So first step is we need to check whether tree is empty or not. If tree is empty, we'll print a message and we'll stop the execution of the deletion method. If tree is not empty, then I need to find the given node in the tree. So find the node. To delete the node, first we need to find the node, right? We need to check whether that node is present in the tree or not. If node is present in the tree, we need to delete that. If node is not present, we need to print the message that is node is not present in the tree. So the second step is we need to find the node. And if the node is present, then I need to delete that node. Okay, so these are the three steps of the deletion method. First, we need to check whether tree is empty or not. If tree is not empty, then we need to proceed to the next step. That is, we need to find the node in the tree. If node is present, then only we need to move on to the third step. That is, we need to delete that node. Clear, right? So let's write the method. In the Python file, here I have class BST. In BST, I have insert method, search method. Next, we have traversal method, pre-order, in-order and post-order. Next, here we'll define the delete method. So def, I'll take method name as delete. You can take any suitable name. Next, here we want parameter. The first parameter is self, which will represent the object itself. The next parameter is data of the node which I want to delete. While calling the delete method, we need to mention which node we want to delete. We need to mention the data of the node. That's why this parameter data. Alright, colon. And here I need to define the delete method body. So here the first step in the deletion operation is I need to check whether tree is empty or not. Now the question is how to check tree is empty or not. If you remember, while discussing about the insert method, we discussed about this case. In our program, if tree contains only one node and if that node's key is none, then I'll treat that node as empty node and I'll consider that tree as empty tree. So here I'll take the condition as if self.key. Here self is representing the object. Here if I call this method as root.delete, because here the object name is root, right? So if I call this as root.delete, then here self.key is nothing but root.key. If it is none, then I'll take the tree as empty. And here I'll print a message. If this condition is true, you can print this message. I'll print the message tree is empty and here I'll use return. That is, after printing this message will come out of the method. We don't need to do anything else, right? If tree is empty, that means we can't delete any node from that tree. So we'll just print this message and will come out of this method. And if you want, you can take if self is none also. That is, self represent the object. If object is not present, that means tree is empty. If you want, you can take that condition also. But for our program, this condition suits better. Next, if tree is empty, we'll print the message. If tree is not empty, then what we need to do? We need to find the node, whether it is present in the tree or not. If it is present, then where it is present. We need to find that node. In other words, we need to perform the search operation. We need to find that node is present or not. To perform this case, you can call search method. Here we already defined search method, right? You can call this search method and you can find the node is present or not. If node is present, then where it is present. But here in our program, this method is not returning any result. That's why I'm not using this method in the delete method. But if I modify this method to return the result, then I can use that method here to find the node is present in the tree or not. But here I won't do that because I already explained you about how search method works. If I modify that, you will get confused. That's why I'll write the separate condition for search method here. So here, to find the node, a node can be present in the left subtree or in the right subtree, or it can be equal to the root node. The data of the given node can be equal to root node. We have three conditions, right? If the data of the given node is less than the roots key, then that means the node I want is present in the left subtree. If data of the given node is greater than the roots key, that means the node which I want is present in the right subtree. If both this condition is false, that means the data of the given node can be equal to root node. We have these three conditions to check. So here, first I'll check if data, here this data, the data of the node which I want to delete is less than self.key. If this condition is true, then the node I want to delete is present in the left subtree or it is not present in the tree. If it is present in the left subtree because data of the given node is less than self.key. Okay, so that's why what I'll do is I'll call self.lchild.delete. I'll call this method recursively on self.lchild. Here we have tree like this, and we know the node which I want to delete, if it is present in the tree, then it is present in the left subtree. So no need to apply this delete method on the whole tree, right? We can apply this delete method on the lchild only. So that's why we are calling this self.lchild.delete on the left child, and here I'll pass data. So to delete the node, go to the left child of the roots node. And here this method will return some value. For example, here, look, if I want to delete 10, first I'll check 10 is less than 100. True, right? So that means I need to call delete method on this now, left child. After deleting this, here in the left child of this node, I need to store none, right? Here this node left child will be none. After deleting this node, I'll return none and I need to store that here. Where? In the L child of this node. So here, that's why this method will return a result and we need to store that in the self.lchild. I know it is confusing. Don't worry. In the next tutorial, I will explain you this with the examples. So at that time, you will understand why we need self.lchild and how it works. Look, data is less than self.key. We need to go to the self.lchild and we need to apply delete method there. But if self.lchild is not present, then what we need to do? If self.lchild is none, then none.delete, it will give error, right? So here, for example, in this tree, it doesn't contain self.lchild. So now if I apply this, I'll get error. So before performing this, what I need to do is, I need to check if self.lchild, if it is present or not. First I need to check that lchild is present or not. If it is present, then perform this operation. If it is not, else, that means given key is not present in the tree, right? Here you can see in this tree, if I mention 2 and it doesn't contain any left child, so if 2 is present in the tree, it need to present in the left side, but left subtree is empty, that means that given node is not present. So here I'll print this message. Okay, this is when data is less than self.key. Elif, if data is greater than self.key, that means I need to go to the right side and I need to delete that node. If it is present, I need to delete that node. So I'll write the same code like this. First I'll check self.rchild whether it is present or not. Right child is present or not. If it is present, then I'll perform delete method on the right child and I'll store that result in the self.rchild, right? If self.rchild is present, I'll call the delete method on that and I'll store the return result in the self.rchild. Else, I'll print the same message, that is given node is not present in tree. Next here, else. Look, first we'll check whether tree is empty or not. If it is empty, we'll print this message and we'll come out of that method. If it is not empty, then I'll check whether data is less than self.key. That is finding the position of the given node, the node which I want to delete. So first I'll check whether it is present in the left subtree. Next I'll check whether it is present in the right subtree. If both this condition is false, then that means the node which I want to delete is root node. Because here we can see, if the data of the given node is less than self.key, then that means it should present in the left subtree. So we took both the condition, if it is present or if it is not present. Then if data is greater than self.key, that means it need to present in the right subtree. So we wrote the condition for that. If it is not present in the left subtree and if it is not present in the right subtree, then that means the node which I want to delete is root key. So that's why I'll just take else. Here I won't write any condition for that. That is, I won't check like this, self.key is equal to data of the given node. I want to do that because if both this condition is false, that means the node which I want to delete is the root node. Okay, no need to write the condition for that. And in the else part, what we need to do, so using this, we now found whether the given node is present in the tree. If it is present, where it is present. After performing this operation, now self will point to the given node, the node which I want to delete. For example, if I want to delete 10, now self will be pointing to here. This node is self now. Now what I need to do, I need to perform third step of the deletion operation, that is delete that node. Before deleting that node, we need to check the number of its child nodes. If the node which I want to delete contains 0 child nodes, then we need to perform a separate operation, that is just delete the node. If I want to delete a node which contains 1 child node, then that child will replace the parent. And if it contains 2 childs, the node which I want to delete, if it contains 2 child, then either I can replace the greatest value in the left subtree with the parent or the smallest value in the right subtree with the parent. I already explained about this operation in detail with example in a video. I will give you the link of that video in the description box. If you have any doubt here how it works, you can watch that video, okay? Now that means I need to write the separate condition for these 3 cases. Now if I want to delete a node with 0 child, for example this node, okay, this node doesn't contain any child node, right? 0 child. Now if I want to delete that, what we need to do? We just need to delete this node and we need to store here none. And if I want to delete a node with 1 child node, that is if I want to delete this node, then at that time we need to replace this parent node with its child node. So here I'll write the condition for that. Here I'll check first if self.lchild is none. As I said, after performing these operations, now self is pointing to the node which I want to delete. So now self.lchild is nothing but the left child of the node which I want to delete. If self.lchild is none means one of the child of the given node is none. If lchild is none, what I'll do is I'll take a variable called temp and here I'll take self.rchild and I'll take self is equal to none and here I'll take return temp. Okay, now what I'm doing here, when I want to delete this node, here we can see self.lchild is none. This is self, so lchild is none here. At that time what I'll do is I'll take temp equal to self.rchild, that is I'm taking a variable temp and I'm storing self.rchild, so that is none here. Self.rchild will become none. Next here I'll delete self, so I'll take self equal to none, so this will become none. Then I'll take return self.rchild, so it will return self.rchild and it will return none to here, this node, and that will be stored here later. Now it will apply for this also. When self.lchild become none, temp will become self.rchild, that is 3100. Then it will delete this self, so it will delete this. It will return self.rchild, so self.rchild is 3100, that will be returned here and it will store 3100. It will become like this. Okay. Next here, if self.rchild is none, what do we need to do? I need to take temp equal to self.lchild, self equal to none, return temp. Here I am taking case 1 and case 2 combined. As I said, if node contains 0 child or 1 child, both this condition will apply. If it is contains 0 child or 1 child, if self.lchild is none, then whatever stored in self.rchild, return that. If self.rchild is none, whatever stored in the self.lchild, return that. Here, while deleting a node, as I said, we need to check whether node contains 0 child, 1 child or 2 child. When the node which I want to delete contains 0 child or 1 child, you can write the condition like this. If the node which I want to delete contains 2 child, then how to delete that node? So for that, here if I want to delete this node contains 2 child nodes. At that time, what I need to do is either I can replace this parent node with the node which contains largest key in the left subtree or the node with the smallest key in the right subtree. Here I'll go for the second option, that is I'll replace the parent node with the smallest node in the right subtree. The node with the smallest key in the right subtree. Here it contains only one node in the right subtree, so I'll replace this node with 70. It will become like this. Actually here deleting the nodes means what I'll do is, first I'll replace this 50 with 70, then later I'll delete this node. For example, if I want to delete this node, I need to replace this node with the smallest value in the right subtree. So what I'll do is, I'll make this value as 300 first. Then I'll delete this node. Before deleting the node, first I need to find the smallest node in the right subtree, right? So for that, what I need to do is, I'll take a variable here. I'll take node. You can take any variable. And here I'll take self.rchild. Then here I'll perform while.lchild node is equal to .lchild. What I'm doing here is, before deleting the node, what I need to do is I need to find the node with the smallest key in the right subtree, right? So for that, here if I want to delete this node, this will become self. First I'll take its rchild. So I'll take node equal to self.rchild. So now it will become this. The smallest value in the right subtree will be present in the left side, right? Here in this tree you can see this is the smallest node in the right subtree. Because it doesn't contain any left subtree, that's why this is the smallest node. In this tree here you can see, if you want to find node with the smallest key, then it is present here, right, in the left child. Here that's why I'll take while node.lchild until lchild becomes none. I need to take node equal to node.lchild. Okay, it is like this. So this is node now, self.rchild. Now to find the node with the smallest key, I am using while loop and I'll take while node.lchild until this lchild becomes none. I'll take node equal to node.lchild. So now after executing these lines, node will point to the node which contains smallest key in the right subtree. Okay, now what I need to do is, I need to take self.key is equal to node.key. As I said, we'll find the node with the smallest key in the right subtree. Here in this example, this node. So node is pointing to here now. Now first step is, I'll replace this node key with this key. So it will become 300 now. Now what I need to do is, I need to delete this node. In short, what we are doing is, we are not deleting this node. Instead of that, we are changing its key. So now how to delete this node? This is the node with the one child. So we already wrote the condition for that. So here what I'll do is, to delete the node now, self.rchild, because it is present in the right child. We are doing the changes to the right child. Self.rchild delete node.key. I know it is confusing, I'll tell you. While deleting the node which contains two child node, we have two options. One is, either we can replace that node, deleting node, with the node with the largest value in the left subtree or node with the smallest value in the right subtree. I'm picking second option here. So what we'll do is we'll replace the node with the node which contains smallest value in the right subtree. So here, if I want to delete this node, what I'll do is first I need to find this node with the smallest key in the right subtree. That's why first I took node equal to self.rchild. Here this is the node which I want to delete. That's why self is pointing here. So if I take node equal to self.rchild, this is the node now. This is the right child. Now I want to find the node with the smallest key in the right subtree. For that I am using while loop. The smallest value of any tree will be present in the left side, in the left child. If left child is empty, then the root node will be the smallest node. Okay, consider this as the tree now. Here also you can see in this example, smallest node is this. It is present here. So to reach that, I am using while loop. After executing these lines, node variable will point to the node with the smallest key in the right subtree. Here in this example, this node. Now what I need to do, I need to replace this node. This is the node which I want to delete with this node. So for that what I'll do is I'll first replace its key. So here I'll take self.key is equal to nodes.key. So it will become 300. Now what I'll do, it is replaced. Now I'll delete this node. So to delete this node, I'll call self.rchild.delete node key. And later here in outside the else, I need to return self. Okay, I need to return the value here self. Okay, so now we are done with this delete method. So first we need to check whether tree is empty. If it is not empty, then we need to find the position of the node, the given node where it is present. After finding the position, we need to check whether it contains 1 child or 0 child or 2 child. If it is 2 child, then we need to perform this operation. I know you have confusion. Don't worry. In the next tutorial, I'll clear all your confusion. Okay, now let's call this method and see whether it works or not. So root.delete, I'll delete all this. I'll call root.delete, and here we have these many nodes. I'll delete 6 first. So here we can see 6 is deleted. If I take 60, which is not present here, you can see given node is not present in the tree. And if I want to delete 10, that is the root node, here you can see 10 is deleted. So 98 is the root node now. If you want to check manually, you can write down the tree and you can see. Alright, so this is about the deletion operation. In the next tutorial, I'll explain you this method with the example. That time you will get the clear picture how it works. So that's it for now guys. Thank you for watching. Don't forget to subscribe to my channel. I will meet you in next class. Till then, take care.